to So You Want to Scale Security. My name is Kuenzli, author of Effective IAM for AWS and founder of K9 Security. As a consultant, I led migrations to AWS Cloud using continuous delivery for several years. And the hardest part about that experience was getting security right. In particular, no one knew how to configure IAM policies or what they really allowed. And we were always afraid. You know, there was this risk bubbling up from our delivery pipelines and from our VPCs. There was usually one or two people brave enough to write IAM policies, and they ended up doing all of that work, which meant they were overloaded and couldn't go on vacation without feeling guilty. So I set about to productize and scale that whole process. And what I'd like to share with you today is the simple security program that we end up using to do that. Because the number of workloads is growing fast, and the gap of security specialists is growing even faster. So a lot of organizations are going to double or triple their cloud deployments in the upcoming years, and we need to be able to figure out how to scale security. And this post by AWS Security of the AWS CISO's predictions for 2023 caught my eye the other day. It features the ISC Squared 2021 Cybersecurity Workforce Study, which says that in 2021, there were 4.19 million cybersecurity professionals, and there was a gap, as reported by this workforce of 12,000 or so surveyed respondents, of 2.72 million people, which is 65% gap. But security has a scaling problem. 2.72 million people is a lot of people, and that's the current workforce gap. The 2022 study, which actually came out just about the same time as that tweet, showed a gap of over 3 million, and the workforce gap was 72%. So it's getting worse. And to put that gap in perspective, there are 730,000 science, technology, engineering, and mathematics graduates that will be awarded degrees from associates to PhD this year, and about 2 million or so worldwide. So what this workforce study is saying is that even if we took all the people with STEM degrees and convinced them to come into security, foregoing all of the engineering, science, healthcare, and other jobs, that it still wouldn't cover the gap. Now, I'm not saying that STEM degrees are the only or even best qualifier for security. It's just trying to put this in perspective. And I think there's some deeper questions here, like, could organizations expand by their budgets by 60 or 70% to cover this gap if the people were available? Would they? Is this a good use of people's lives to largely take care of security after application infrastructure teams have deployed it? And is security somehow different than other technology specializations, like reliability, let's say? I think at this point, it's time we think about how to do security differently. And the fact is, there are some organizations that have figured it out, and it's by scaling security with non-security specialists. So before we talk about scaling secure delivery, let's identify what's constraining it. Theory of constraints is a methodology for identifying the bottleneck that is constraining throughput within a system or a process. And an approach to improving that throughput is to basically work on that bottleneck until it's no longer limiting the throughput in a way that you care about. And in fact, there's no use, essentially, in working on anything but the bottleneck if you want to improve the delivery and throughput of that system, mathematically. Politically, maybe there are reasons. But it's one of the theories, theory of constraints is one of the theories underlying lean, software development, agile, and DevOps methodologies that we've been using for the past 2 decades. In traditional security models, people are the constraint because they have specialized skills. There are many specialists in security. There are people who know how to write IAM policies, configure networks, configure firewalls, configure the fancy detections and the SIMs and so forth. But when security changes have to be done by one or two specialists in the org, what happens? The change is likely to block, throughput drops, and customers and the business is unhappy. And honestly, the specialists aren't very happy either because they're getting run over by all these requests. Specialists are bottlenecks. So what can we do? We can try to dissolve the bottleneck by decentralizing security. And AWS has famously done this, amongst other companies. And in AWS's recent paper on security operations, they talk about, or they recommend that organizations adopting a decentralized or hybrid security operations model, where security operations is done mostly locally, and then governance is done centrally. Well, they recommend that you incorporate cloud security practices early and then throughout your delivery process. Because when we decentralize, we can theoretically scale security and changes to flow to production without the need for integration and approval, let's say, of a specialist. But now we have two different problems. Because when security is everyone's job, application teams need to be able and motivated to do that job. So we need to take security specialists out of the delivery pipeline and refocus our efforts in two areas. First, on building artifacts and tools that cloud and app teams can use within their pipelines. And second, building a culture that motivates the organization from the individual all the way to department level and higher to actually implement these security processes and deliver securely. So now that we have a plan, let's dig in. Engineers need to be able to apply the organization's best security practices, or security best practices self-service. This is primarily a usability problem in my view. So Don Norman, usability expert who wrote The Design of Everyday Things, who will explain like why remotes are and are not easy to use, created a model that describes how a person goes about delivering or achieving their goal. And if their goal is to secure IAM, the engineer has to traverse two gulfs, the gulf of execution and the gulf of evaluation. In the gulf of execution, the engineer asks, how do I work this? What can I do? This is like, what does this IAM policy, like, what is the form of an IAM policy? What are the permissions related to this service to enable my application? And they try to apply that knowledge in their head to the world. And they do that by writing policy. And then they need to cross the gulf of evaluation and understand what happened. They translate what happened in the world, i.e. AWS, security, and say, did I get what I want? Can my application read data from its bucket? Can the CI/CD system not delete the production database? And they go around this loop and try to converge it. And the faster they do this, the happier everyone is. Okay. Now, and we also need to motivate engineers. And engineers, teams, and entire organizations to go around this loop of applying security best practices while doing the rest of their job. This means knowing how to prioritize security along with all of their other responsibilities. So let's take a look at a framework for how you can use this within your organization. So here's the framework for building a simple security program that scales. The framework is built on the proven methods of changing organizations, described in the book Influencer, the new science of leading change. So I use this framework. It's for everyone. In fact, most of the case studies have nothing to do with technology. It's like, the question was, is Influencer for technology or for people? And it's really for everyone. It's very broadly scoped. And as a consultant, I successfully use the general framework in Influencer to improve quality, improve reliability, and improve security. So we're going to give people both the ability and motivation to secure their systems. So we've got two dimensions going to the right, and we're going to do that at 3 levels of scale: personal and individual, social, which is like your team, your local team, and inter-team interactions. And structural, so department-wide and interdepartmental interactions, governance type stuff. You can do them all, but today we're going to focus on the 4 that are going to deliver security and scale security quickest. Okay, before we get into the specifics of this framework, I want to quickly remind everyone what success looks like. Success means strong security is delivered continuously in the organization's delivery processes, leading to safer operational environments and unloaded security experts. Sounds good. And the secret is that simple scales. The big idea here is you need to productize and operationalize security like you do other things, like reliability. This is important because there's no magic bullet. You're never going to make everyone into AWS security experts, and it wouldn't even work because the experts get it wrong frequently too, especially when we're talking about subjects like advanced IAM. You need the whole organization to be able to operate at a higher level of abstraction. So the first step on our happy path to scalable security is to increase the ability of individual engineers, application and cloud engineers, to build more secure systems. Currently, most organizations have at least 10 times as many app and cloud engineers as they do security specialists. And the app engineers' security requests are custom and one-off, which means the cloud security specialist often has to interrupt their work to respond to some change that needs to be done to get the change to production in a reasonable amount of time. We need to flip that script. Cloud security specialists should adopt or build components and reporting that provide simple and easy to understand solutions that fit within the organization's reference architectures. So this means you can protect data from unintended access, scope people and application principals access to least privilege, and review access and converge it to what is intended, all without requiring experts. That's what we need to do. And boom, if you do this, now you have 10x more engineers who can do security. And further, this creates a bunch of positive results. You increase the ability of your entire organization to build more secure systems. You scale that load. And further, once you productize security, you make it available for practice and training in safe environments. So, how should engineers actually specify their intended access control? Let's see how engineers should be able to do this. We'll look at just the interface here and see what usable control automation should look like. Suppose a quick discussion within an application team reveals the principles that should be able to access the application's data. First, the team translate their intended access into variables that define the principals who should have access to each capability. So the CI and operations role should be able to administer this KMS key, this KMS encryption key. And then team A and team B should be able to read the data encrypted by this key. And team A should be able to write data encrypted by this key. And that should be it. Then we assign that to a key policy generator. So we've successfully lifted up the conversation from the low-level details of IAM security policy to a language non-experts can understand and review. No mucking around in AWS docs or inaccessible data from broken policy. Because we hand that off to the key policy generator, which generates the 150-odd lines of key policy that allows the intended access and denies everyone else. And I like to say that friends don't let friends write key policy because it's really hard to do correctly. So we've open sourced our implementations of this. You can find them for Terraform and CDK at the GitHub URLs below. They're free. Feel free to use it, or clone them and modify them for use in your own organization, using your own terminology, if you like. But the key is, it's like, let's raise the level of discourse and a level of abstraction for important operations like who has access to data. So you should also be able to review access to data in that same policy, or in that same language. So reviewing access is nearly impossible for humans to accurately perform in most production environments because of the flexibility and complexity of IAM and just the broad scope of what's happening in production accounts. But it's easy to perform essential access reviews with a simplified access model generated for you. So in this example, it's easy to see that the firewall role can read data from hundreds of buckets in addition to being able to write to the logs bucket. You may remember this from a famous breach a couple years ago. So if the networking team is reviewing this, they should quickly come to the conclusion that they need to go and improve their policy. They have a vastly over-provisioned or over-permissioned principle that is on the edge of the network. And conversely, when the credit applications team is reviewing access to their resources, including the credit applications bucket, they should notice that there are principles like firewall role with unintended access to their data. So hopefully you can start to see how we can scale IAM access without requiring an IAM specialist. You can probably also see that we can automatically review resources for compliance using the simplified access model. So say we have a rule like data that is tagged with a data classification of restricted should only be readable by at most 5 principals. Well, we could probably implement an AWS config rule to check that for us. This example has been focused on identity, but the approach extends to other domains, networking, dependency management, etc. The key is to simplify the domain so non-specialists can understand what to do. Then you can scale security. The second step on the happy path to scalable security is to build social support by gathering your security champions and your security experts and your security curious into a security guild where engineers can ask for help. The most successful organizations like AWS and Datadog develop the security curious into a role called security champion or security ambassador with training and support. And these are like formal training programs. But you can build your organization's social ability by creating a security guild that develops, supports, and encourages security within your organization. The guild can congregate in an open group chat channel. Engineers can get help from people with both formal and informal security responsibilities. So guilds are a great way to scale the support load, surface problems with components, tools, processes, and identify and document frequently asked questions. And now you have 10x more engineers that can support security. The third step on the happy path is to build your organization's ability to manage security at scale. So do that by integrating the security information required to execute your security configuration and review processes into your existing workflows. We don't need new tools to see security information. This enables engineers and managers to review security information in the tools they're already using. Typically, this means integrating with delivery pipeline systems like GitHub Actions and Jenkins, infrastructure code libraries like CDK and Terraform, monitoring systems like Splunk and Datadog, compliance systems like AWS Config and Security Hub, and issue management systems like Jira. There's a lot of touch points where security exists, and it makes sense because it's a cross-cutting concern. Security information needs to be present in the place where engineers and managers do their jobs. Or the case could be made that it's not really their job. Every time you force people to look in a special place for security information, there's a switching cost, manual data integration cost, and reinforcement that security is somehow different from their other activities. So let's see how our program integrates security into the continuous delivery process. First, application engineers can use secure infrastructure code libraries to provision access controls for principals and data using a high-level language. Words like
administer resource, read data, write data, like we saw in the KMS example. And then they should be able to review what the actual access is at any time using those same high-level words to verify that the access is as they intend. Because of course there's a lot of things going on in modern delivery processes, including manual operations, conflicting control planes, etc. So we can't always trust what is in source control, what our infrastructure code says is happening. We should actually go and verify what the real thing is in production. And then finally, enable the whole organization to review who has access to APIs and data using simple processes that exist in their existing tools. Because we've simplified the model so much, we can have the security reviews make sense in people's existing monitoring systems, SIMs, XDR, etc. Let's see, anything else here? The key is to make this self-serve, integrated, and scalable. So have you protected or productized something like reliability in the same way with well-built infrastructure code components for auto-scaling and monitoring? Does this make sense for security too? That's all we're really doing here. Now you may be thinking, this may be a lot to build ourselves, and you're kind of right. But the main thing to understand here is that you can adopt pre-built solutions and plug them into your own program. So in fact, pre-built AWS, open source, and commercial components exist for each element of this program. The key is to assemble the right set for you. So the fourth and final step on our happy path to scalable security is to motivate individuals to do the work. You can motivate your engineers to do the work first by giving engineers control over when they do that work. Once you integrate security into your workflows and alongside other daily work for functional reliability and maintenance improvements, you make it easy to prioritize and execute security along with that work. Realistically, most security work is probably a medium priority. So set clear expectations and requirements around what security priorities are and let teams execute it according to those documented priorities. And then you can hold them accountable at some point to those standards at a departmental level ops review. Second, you can use game day exercises where engineers can experience the outcomes of what poor security looks like. So set up a vulnerable environment, ideally with their own application, or as it is, right? Give them instructions on how to exfiltrate or destroy data. And that way they can experience a bit about what that's like from the safety of a test environment that is safe that protects customers and the company. This builds empathy for why adopting the new practices is important and how little effort can go a long way to protecting customers and data. Okay, so you want to scale security? Remember, security only scales if your process scales. So think through how security should integrate with your delivery and operational processes. The solution to the security workforce gap is probably not 65% more specialists. Instead, simplify security to enable people to deliver securely with their existing processes and tools. Make the set of people who can do security 10x bigger. Organizations are already using these models successfully, this model and methods successfully. So many of the tools, libraries, and frameworks you need to plug in already exist and are getting better all the time. So take a look and see how you can scale security by enabling and motivating your delivery and operations teams. Thanks for listening, and happy to discuss any questions that you have. Thank you for listening, and go fast safely. Yes, I wrote a book, Effective IAM for AWS, which talks about actually what we just covered in much more detail, especially chapter 7 is the basis actually for this talk. So the question is, how would you define the difference, or similarities even, between SecOps folks and DevSecOps folks? Is that accurate? Oh, security engineering ops. Okay, yeah. So what is the difference between security engineering and ops and DevOps, DevSecOps folks? It depends a whole lot on the organization, what the difference is. So in many organizations, security engineering, especially when it relates to cloud, ends up sort of defining what I call the paper policy of how we secure assets in the cloud. But many times, they're not the ones writing actual security policy or configuring actual security controls in AWS. That often falls to the actual hands-on practical execution of that falls to cloud, DevOps, site reliability engineers in many ways. Now that gap is closing, but the key, especially within the DevOps space, is that we need to be collaborating here. And whether you're doing security as a DevOps person, which is, hello, me, or you're a security person who is coming and you've shifted right, maybe, I guess the correct term would be. The key is to actually collaborate and solve these higher level process and delivery problems that yield a more secure organization. Sure, yeah. Yeah, hashtag DevSecOps. And I think it's important to take the information we talked about and put it into everybody's existing job. We mostly work, so the question is, when we are talking about scaling IAM, who do we end up working with the most? And we often work most with basically the VP of engineering on down, the organization who has operational responsibility for the cloud, and is getting things in and out of the cloud. But that's changing and probably should change over time and can vary by organization. So. Who is the right title? Well, I think the teams that respond most to this kind of conversation are typically, it's like a director of SRE, site reliability or cloud, whoever is feeling the pain of writing policies. Okay, like the resource in most contention are people who know how to write good IAM policies in our world, and actually do the actual on-the-ground configuration. And so what we want to do is we want to productize that and scale it so everybody can do it and release that bottleneck. Okay, so I think we're done. Thank you.